Okay, the following is a video over 2.8 notes, and this is proving angle relationships. And what it has us do in problems 1 through 3 is find the measure of each numbered angle, but we got to justify our work. We have to provide reasons why we're doing things, okay? So the first thing I want to do is I'm going to write out that angle 1, in this case, plus angle 2, if I add these two angles together, I get 180 degrees, okay? And the reason for that is because these angles are supplementary, okay? They form a linear pair, supplementary, okay? And so now what I'm going to do is I'm going to substitute x plus 10 in for angle 1, and I'm going to substitute 3x plus 18, okay, in for angle 2, and that's equal to 180. All right, I'm going to combine my like terms here, and I get 4x plus 10 plus 18, which is 28, is equal to 180, okay? And then I'm going to go ahead and solve for x. So if I subtract 28 from both sides, all right, that's going to give me 152. So I get 4x is equal to 152. If I divide by 4 and divide by 4, okay, what's that going to give me? That's going to give me, pretty sure it's 38. So 152, divide that by 4, that gives me 38. All right, so x is equal to 38. Now, what they want me to find is the measure of angle 1 and the measure of angle 2. Okay, so angle 1 is x plus 10. So angle 1 is equal to x plus 10. So let's substitute 38 in for x, and so I get 38 plus 10, and so I get that angle 1 is equal to 48 degrees. Okay, and then angle 2, what was that? 3x plus 18. So we get 3x plus 18. If I substitute 38 in for x, I get 3 times 38 plus 8, 18. So multiply that by 3. That's 114. So 114 plus 18. And then I'm going to get that angle 2 is equal to 132. Okay. Now, I didn't really justify all my steps. I spoke them, okay? This, from here to here, I combined like terms. From here to here, I subtracted. From here to here, I used division. And then from here to here, I used substitution. So substitution. From here to here, I also used substitution, okay? So this is a pretty standard problem that we do in geometry, okay? Let's go ahead and take a look at number 2, all right? And what it wants me to do on this one, it says find the measure of each numbered angle. Okay, I know that angle 3 is equal to 90 degrees, okay? Because I know that this angle here is 90 degrees, this is 90. Okay, this forms a linear pair. So I know that angle 3 is also 90, okay, because these lines are perpendicular, then all the other angles are 90 degrees. Okay, now the other one I need to look at is the sum of angle 4 and angle 5. If I take angle 4 and add angle 5 to those, then I'm going to get 90, okay? And these are complementary angles, complementary, okay? And so what I'm going to do now is I'm going to substitute my values in for angle 4 and angle 5. So I've got 2x minus 5 plus angle 5, which is 4x minus 13. And that's equal to 90. Okay, so if I take 2x and 4x and add them together, I get a total of 6x. If I take negative 5 minus 13, I get minus 18 is equal to 90. Okay, so then if I add 18 to both sides, then I get 6x is equal to 108, okay? Now, if I divide both sides of that by 6, then I get x is equal to, I think that's 18, pretty sure it's 18. So if I take 108 divided by 6, it gives me 18. So x is equal to 18, all right? So now that I know that x is equal to 18 in this case, I got to substitute it back in for angle 4 and angle 5 to find those measures. So angle 4 is 2x minus 5. So angle 4 is equal to 2x minus 5. If I substitute 18 in, I get angle 4 is equal to 2 times 18 minus 5. So that's going to give me 36 minus 5, which ends up giving me 31 degrees, pretty sure. Okay, so it's angle 4 is 31 degrees. All right. Now let's find angle 5. Okay. So angle 5, if I found that, that's 4x minus 13. So let's write that down here. Angle 5 is equal to 4x minus 13. If I substitute 18 in for x, I get negative 5. Angle 5 is equal to 4 times 18 minus 13. Okay, so 4 times 18, it's going to give me 72 minus 13. So if I subtract 13 from that, I should get 59 degrees. Okay, and that's angle 5. All right, there's that. All right, so again, if I go back through and justify each of my steps, okay, these are complementary. I substituted, all right, these values in for angle 4 and angle 5. I combined like terms. I then added things to both sides. I then divided things on both sides. Okay, then I use substitution here. Okay, and then I use substitution down here. All right, so that's how we do that one. Okay, let's take a look at number 3. Number 3 gives us 2 vertical angles. Now, what I know about vertical angles is that if they're vertical, if they're across from each other, then they're congruent. Okay, so I know this. I know angle 6 is congruent to angle 7. Okay, and they're vertical angles. Vertical angles. All right, so now if my angles are vertical and that means they're congruent, so I can set these two expressions equal to each other. So I'm going to set 7x minus 24 equal to 5x plus 14. Okay, I'm going to go ahead and subtract 5x. I'm going to solve for x here. And I end up getting 2x minus 24 is equal to 14. All right, so if I add 24 to both sides, add 24, that's going to give me what, 38? So I get 2x is equal to 38. And if I divide that by 2 and that by 2, x is going to equal 19. Okay, so now I found out what x is, but I need to plug that back in. I need to find out what angle 6 and angle 7 are. So angle 6 is 7x minus 24. Angle 6 is equal to 7x minus 24. So I'm going to substitute 19 in for that, so I get 7 times 19 minus 24. All right, and that's going to give me, what is that, 7 times 19? 7 times 19, what is that, 133? Okay, minus 24, so if I subtract 24 from that, that's going to end up giving me 109. Okay, so angle 6 is 109. Now, here's the thing, guys. Because I know that these angles are congruent, okay, angle 6 is 109, that means that angle 7 also has to be 109. Okay, so that's 109 degrees. All right, so now let's take a look at our steps, see what we did. I set these two equal to each other. That was substitution. Okay, I used subtraction, and then I used addition, and then I used division. Okay, and then I used substitution again. Okay, here. But then the interesting thing is here is how I automatically just knew that angle 7 was equal to 109. That's because these are vertical angles. Okay, and there are reasons why I do all this stuff. I'm not just picking the stuff out of thin air. Okay, I'm creating this based on the properties that I'm given. Okay, so let's take a look at the next one. And this is number 4. This is proving angle relationships. We want to write a 2-column proof, and let's write out our statements. Okay, and our reasons. Okay, so our first statement, number 1, is that angle 1 and angle 2 form a linear pair. Okay, and the reason I did that is because it's given. Okay, step 2 says that angle 2 and angle 3, let me do that a little bit better here. Second step, angle 2 and angle 3 are supplementary. Okay, and that's also given to you. All right. Okay, so now let's see what we can conclude about this. Okay, if angle 1 and angle 2 form a linear pair, then my third step that I can say is that angle 1 plus angle 2, those add up to 180. Okay, and that's the definition of a linear pair. Linear pair definition. Okay, now the other thing I can say about angle 2 is that, or about step 2, is that if these two angles are supplementary, then these two angles also add up to 180. Okay, that's the same thing. Linear pair and being supplementary are the same thing. Supplementary means they add up to them. Linear pair means that they're supplementary, which means that they add up to 180. Okay, so this is the definition of supplementary angles. Okay, supplementary angles. So some abbreviation. All right, so now here's the tricky part. Okay, the thing is we want to prove that angle 1 is congruent to angle 3. Okay, so now here's the thing. Both of these are equal to 180. All right, so I have this statement here, angle 1 plus angle 2 equals 180. Okay, my question is, what could I replace 180 with here? Now I know that 180 is equal to angle 1 plus angle 2, so I'm going to substitute angle 1 plus angle 2 in for 180 down here. So my fifth step is angle 2 plus angle 3 is equal to angle 1 plus angle 2. Okay, and that's by substitution. Okay, so now what I can do here is now I have a common angle 2 and angle 2. If I subtract both sides by angle 2, okay, subtract by angle 2, then I get my sixth step, which is angle 3 is equal to angle 1. All right, so now step 6 is that I use subtraction. Okay, now, okay, if my two angles are equal, then I can say that the measure of angle 3 is congruent to the measure of angle 1. Okay, and that's my seventh step, and that's the definition of congruent angles. Okay. So, if you want to go back through this, that's a good idea. Let me do the last one just real quick. All right. Number 5, refer to the figure. Barton Road and Olive Tree Lane form a right angle at their intersection. Oh, isn't that nice? This is a right angle. Okay. Means that this is also a right angle, this is also a right angle, and this is also a right angle. Okay, they're perpendicular. It says that Tryon Street forms a 57-degree angle with Olive Tree Lane. So this is 57 degrees. And then it says, what is the measure of the acute angle Tryon Street forms with Barton Road? Okay, so now it wants to know what's this angle measure right here. Okay, so here's what I'm going to do. I know that this is 90 degrees. Okay, so I'm going to set up an equation and say that x plus 57 is equal to 90 degrees. Okay, so if I subtract 57 from both sides, okay, what am I going to get? I'm going to get x is equal to 33 degrees. That's what this is. This is 33 degrees. Okay, so, guys, let's just make sure that we're going through this, that we're watching the video, that if you have questions, you're writing them down. Hopefully, this isn't too terrible for you. It's just an extension of what we're doing, but we're using angles. So you got to make sure you remember all of the vocab that's associated with all this. Okay, so I hope you enjoyed this video. I had a lot of fun making it, and we will see you soon. Thanks.